Okay, so welcome back. So now we're going to do another example of taking the second derivative of a parametric curve. Okay, so here's the information. So we want to take the second derivative, find the second derivative of given these parametric equations over this interval. Okay, so again, what do we need to do? Well, we need to take the derivative of both of these, right? Because remember, the formula is the derivative, right, with respect to t of dy dx over the derivative of x with respect to t. Okay, so we start by finding this and this. Well, to find this, we also need to find this, right? So again, we're keeping in mind that dy dx is equal to dy dt over dx dt, which again is just, y prime of x over x prime, not of x, y prime of t over x prime of t, right? So what is x prime of t? What's the derivative of x? What's the derivative of x with respect to t? It's just what? 2t minus 4. Oops, sorry. That goes on the bottom. T minus 4. And then the derivative of y with respect to t, right, is going to be 6t minus 6. Okay, and of course we've seen this before, and so this factors out to 6 over t minus 1 over 2 times t minus 2. And so this gives us 3 times t minus 1 over 2 times t minus 2. So there's our dy dx. Oh, hold on. That's wrong. Should just be 3. Okay, now we're ready to find this. So now what we're actually doing is we're going to find the next derivative, the second derivative with respect to t of dy dx, which is this, right? So now what we're finding is d dt of what? 3 times t minus 1 over t minus 2 divided by the derivative of dx dt, right? But dx dt, we already know that too. Dx dt is right here, which is 2t minus 4. Okay? Now, how do we take the derivative of this here? Here we've got a quotient. So we're going to have to use the quotient rule. So let's use the quotient rule down here. Let's go through this. Okay? So let's bracket this off so nobody gets confused here by what I'm doing. So far, that's one piece, right? So now what I'm going to do is I'm going to now do some scratch work over here, and I'm going to figure out what this derivative is. So that means I'm going to have to use the quotient rule. So it's going to be what? Don't forget the quotient rule. It's low d high minus high d low over low squared. So it's going to be what? t minus 2 times the derivative of the top. Well, the derivative of the top is just 3, right? Minus the top, which is 3 times t minus 1, times the derivative of the bottom, which is just 1, over the bottom squared. Okay. That's what I have. Okay, this is the bottom. So let's simplify this. So what do we get here? Okay, this is going to be what? We get 3t minus 6 minus 3t plus 3 over t minus 2 squared. Okay, so far what I'm doing is I'm just taking the derivative of this. Okay, so now I simplify this, and what does this top become? It becomes what? Well, this cancels with this, and what do I get? I get negative 6 plus 3, which is negative 3. So I get a negative 3 over the quantity t minus 2 squared. So guess what? That's what I'm going to put in here, inside this box. Okay? So now this is what I put in for this. So what does that give me? Well, now this is now going to be rewritten as what? So this whole thing here now becomes what? It becomes negative 3 over t minus 2 squared, right, divided by, well, 2t minus 4, which is just 2, times t minus 2, right? So this whole thing now simplifies to this, okay? So now I'm just going to multiply by the reciprocal of the bottom. So this becomes negative 3 over t minus 2 quantity squared times 1 over 2 times t minus 2. And so now my final answer for the second derivative becomes negative 3 over 2 times t minus 2 quantity cubed. And this is my final answer. So let's recap. So what I did was I found dy dx, right? So I found dy dx. That's the first derivative. And now to find the second derivative with respect to t, right? I go back to use this formula. Well, what's dy dx? Well, dy dx is here, so that's what I put here. Over dx dt. Well, what's dx dt? Right there, right? See, dx dt is 2t minus 4. So now I've got this. Now I'm going to take the derivative of this thing with respect to t. That's what I did here. And I got this, right? So I used the quotient rule. I got this for this. So then I plugged it in. Then this comes down to this. So that's what I did. So I can't, with this substitution here, I come down to here, and now I simplify to my final answer, and I'm done. Have a great day.